so who's familiar with DevOps and infrastructure as code? Yeah? Are you familiar with that? Yeah. Okay, so infrastructure as code is essentially if you want to create for example, a Databricks instance, you could go into your GUI into Azure and just create it there, right? Infrastructure as code essentially is doing that using another third-party tool where you're writing that infrastructure like a blueprint. So the tools that we're looking at, essentially like with Terraform and Bloomy, they've got their own markup language that you can write that, and it's like a blueprint, and you can then work against that. So that is essentially better than having somebody do it in the UI, and then anyone can go in there and start making changes, and you can't then keep control over that and monitor it in the way you could when you've actually got it in like a markup language that you can then have in like source control, and everyone then owns it and can see who's been doing what a lot more easily. Does that make sense?
Yeah.
So Database REST API and Python. So I've got a link there to the Database API documentation, and then any code I'm going to show you is in the GitHub repo there. So essentially, what is it? It's REST API, and it's part of any Databricks instance. So not just on Azure. If you've got a Databricks instance, you will have the Database API that you can work with. Is everyone familiar when we're talking about REST APIs? Yeah. So the Azure documentation can be found there around it again. And you can use it essentially because it's just a REST API with any programming language of choice, or start off using tools such as Postman, just have a play around with it. Why are we going to look at Python? Well, essentially, when we're talking about Databricks, Python is the most common language used. It's the most popular language. So if we want to empower our team so that everyone can do DevOps, if we use Python, then there's going to be a lot more people in your team that can actually feel empowered by it and be part of that DevOps process, which is what we want. So looking at some code, what have we got here? So we have got some Python, which is working with that REST API. Don't have time to show you it all, but you can go to the GitHub repo. What we've got here is we have a method where we're creating a cluster. So we're saying here, this is the endpoint I'm interested in, here's some of the body for the REST API, and then we're using the typical Python requests package to actually then build all that up and actually go away and hit that REST API. And then we just grab our response. And if it's not a do something, in the real world that would be a lot bigger, we do more with it, we log. But this is just our demo. It's actually how we can start building this up. So yeah, REST API there. And then we've created a cluster, but we need to monitor it. We've told REST API we're going to create it, but it could just put its thumbs up at us, and then it doesn't actually succeed. So it's like a fire and forget. So what we've created here is some methods that essentially we're going to get our cluster info, we're going to start the cluster, we're going to restart the cluster, and these can all be used essentially to create a method that is going to monitor our cluster for us. So this is all going to be within our DevOps pipeline. We're going to call these scripts essentially in our DevOps pipeline, and this is a very vanilla way of just writing some Python against the REST API to do our DevOps for Database. So we're looping there. We're basically looping through for 20 minutes and just waiting for that cluster to have a status of running, essentially. So here's the actual YAML that's in the pipeline. So we are using essentially this gentleman here I was just talking to about this. We're using essentially doing everything in the YAML. I know old school pipelines in Azure DevOps, you have the GUI interface where you can set up like your release pipelines and stuff like that. We are using, this was about 18 months ago, they essentially said they're moving more over to just everyone does everything in YAML, so that's what we're looking at here, is essentially we've got a job to create a cluster. We're grabbing all of our authentication tokens from a previous step. Don't have time to show you that, but there is an authentication model with the REST API, which you can work with service principals with. So there's our script, essentially. There's our create cluster. So just YAML pipeline, and then we can call our script as a Python script class. And that's one way we've achieved DevOps, essentially, in Database.
What's the difference between management token and beer token?
So when you're authenticating against the REST API for Databricks. If you're working with a service principal, you need both of those tokens. So there is example code in the GitHub repo. There is a recording of me going into a lot more depth about that, which I'll give you the link to at the end as well. So if you wanted to dig into that, you can.
Is that the one you did in the data AI something?
Yes. Yeah. Have you seen that one? Yeah. So from the previous job again, and then we're doing an upload notebooks to Datebricks script. So it's just an example here. We've got all our jobs, and we're just filing away our scripts that we've created. And it's a way we can perform our DevOps essentially. Yeah, that's our method. So moving on to Terraform, I'll just check this one. So moving on to Terraform, we've got links there to the GitHub repo and then essentially some of the latest docs on Terraform for the provider for Databbricks. So what is Terraform? Has everyone heard of Terraform? Do you know what it is?
Yeah.
Cool. Yeah.
No,
okay.
I'm new to this.
Okay. Terraform is one of the most popular infrastructure as code tools. So I've used it in the context of Azure, but I've also used it with the GCP and AWS as well. So it's very popular, and it's got some really awesome providers that you can work with for some of the most common tools that you'd want to be infrastructure as coding. So it's for building, changing and versioning infrastructure safely and efficiently. We can manage existing popular services, any configuration files describe to Terraform components needed to run a single application or your entire data center, which I was explaining to that gentleman. So Terraform has this concept of write, plan, and apply. So we write the Terraform, it's got its markdown language. So we can write it, so that's our blueprint, and then we hit plan, it tells us what's going to happen. So if it comes back and says it's going to delete something it shouldn't delete, then you panic and say, why are you trying to do that? And then you dig into what's going on. And then we hit apply, and we can actually apply those changes. So benefits, it's got state management, like I said, it will tell you what's going to happen. So you can manage that. It's cross-cloud. It can solve issues provisioning complicated infrastructure. So who's been burned by ARM templates getting out of control? They can get really massive. So Terraform is a nice alternative to that. Bicep is very similar to Terraform. So if you've dug into Bicep or heard of it, and you get to grips with Terraform or Bicep, you can cross over quite easily. We're looking at Terraform because it has such a strong DevOps infrastructure as code provider for Databricks essentially. So there's a lot of traction behind it. There's a lot of people working on it. So, and they're constantly adding to the tooling and improving. So it's a high-level description of your infrastructure. So getting started. What have we got here? This is a load of Terraform. Doesn't make sense to everyone. Essentially, we're saying, I'm going to work with this Azure provider and this Databricks provider. A provider in Terraform is essentially, for example, the cloud provider you're going to work with. We know we're going to work with Databricks, so we download our Databricks provider. So we specify them, and then we can essentially create a workspace. First thing we do is create an Azure resource group, and then we create our Databricks workspace, and it's just that. It's just those 3 lines of code, and that's it. Not even code, just markup. And then we can create a Databricks cluster. And you can add things in there like your Python libraries that you're working with. So if you've got some custom ones, you can throw them in there as well. So you can just add it all there in your markup. And it's really easy to read, and it's easy for other people to pick up. So even if your data teams don't know Terraform, it's quite easy, and I found it very easy to teach to clients so that everybody is using that same tool and they all understand it essentially. And then just an example of uploading a notebook. That's it. We just point to where the notebooks are, and it's base64 encoded, and we can then upload them using that resource. Does that make sense to everyone?
Yeah. Yes, so just one question. If I need to configure like tables, queues, that kind of stuff in Hive, is it supported by these tools?
Yeah, so Terraform is more of an infrastructure as code. So I think what you're talking about is more of a DevOps side of things. So that is where I'm going to move on to, is where you can have a little bit of a combination of things. So focus on your infrastructure as code with one, and then maybe use another to do more granular stuff like that. So kind of split it into two areas really. So that's our end result. It would be a Terraform essentially created workspace in our resource group. So it's important to say that Terraform handles state, so it recognises when you're creating versus when you're amending a resource. You can import existing resources into Terraform and work with them. Terraform picks up on changes that have happened outside itself and lets you know if it's going to change or delete anything. So I don't know if anyone working with ARM and they've made changes, redeployed, and stuff's been lost and massive headache. Terraform is a nice way to essentially gate that for you by working with the state. So it is a really useful tool. So Terraform CLI core commands. So Terraform has a CLI over the top. So you've got the Terraform that we saw that's actually on the markup, and then there's a CLI over the top that looks at your actual Terraform code, and then you can run these commands. So in it is initialize, validate is you're validating your Terraform, and then you hit the plan and apply that we talked about before. So the plan tells you what's going to happen, apply will actually deploy it. So Pulumi and Python. So the Pulumi module for Azure and Datebricks is essentially based on the Azure Terraform provider. So the two kind of work nicely together because of that. So why Pulumi? So you write infrastructure as code in your language of choice, so C#, Python, Go, and TypeScript. And again, we've got a lot of Python users, so that's immediately something that they can pick up and then start working with. We've got our state management again, utilises Terraform providers and can work alongside Terraform. If functionality doesn't exist, it's easy to use an SDK or APIs alongside Pulumi in the same language of choice, which is really useful. So if you're already writing Python, you don't have to then jump into something else. You can just carry on writing Python for your infrastructure as code DevOps. So just getting started. So getting started. So this is just some Python code. We're importing the Pulumi packages. And essentially what you do with Pulumi is you install the CLI, the same as you've got a CLI with Terraform. And then you can start writing your Python. So we import the packages, and then you create a resource group, just to get started. And then this is an example just of the output when we're running that Pulumi up command. So that's the same as you apply in Terraform. You're pushing what you're creating into Azure, and that's an example output there. It tells you what's going to be changed or unchanged, and then it asks you if you're sure you want to do it. So we're going to, here is an example of just creating a storage account. And we grab the key out of that so we can then work with that key. So if we want to connect things to the storage account, we can, because we've grabbed the key. And now this is what we're interested in. We're creating a Databricks workspace. So essentially just a few lines of Python, and you're able to essentially create your Databricks workspace using Python, using Pulumi. And that's your end result. You get a Datebricks workspace, the same as what we saw with the output of the Terraform as well. So Pulumi can only do workspaces, private endpoints, connections, and VNet peering by bother. So that is true because it's based on the Azure API, the Azure Terraform provider, which doesn't have a lot going on with Databricks because you've got the Databricks provider itself. You could ask yourself, why bother? Well, if you're using Pulumi for other things in Azure as well, you can use it for all of that, and then you can combine this with, for example, the Database REST API Python and build it all up again using the same language, which again is really useful if you've got a team of Python developers. So the summary, so you've got lots of options to choose what is best for your team. So if you're coming here waiting for me to give you a unicorn answer of what to do with DevOps for Datebricks, it's really difficult because it's really a case of what talent have you got on your team, what skills have you got, and then analysing what would work best for them. But these are just 3 examples of tools that you can pick up that will help you on that journey to good DevOps for Datebricks. And there isn't a massive amount of kind of documentation out there about the best practices for DevOps for Datebricks, which is why I'm constantly asked, how can we do it? So this is the approach essentially that's worked for me and has worked for the company that I work for, Advanced Analytics, because we're a team of consultants that are always trying to help the teams, you know, empower them, especially kind of along the lines of like DevOps and infrastructure as code. So that's a link to all of the code that I showed you. At the bottom there, that is the talk this gentleman mentioned, which is a recording on YouTube, essentially, that if you're interested in the REST API with Python side of things, you can watch that. And it correlates with that top link there, the REST API for Python. So feel free to reach out to me if you've got any questions. I'm open to questions, criticism, anything you wanna say, then feel free to give me a shout. And finally, thank you. Sorry that I've spoken really, really quickly, but I had a lot to say in 20 minutes.
Not enough time.
Yeah, I hope that's all made sense. And essentially, it was just a top-level overview of a very common question. And so I've given you some examples of how to do it. And hopefully you'll be able to go away with that and it will help you in some elements, in some respect. But like I said, feel free to reach out to me if you want to have a discussion about it. If you've got any other opinions, that's absolutely fine. I'm up for having a chat around it because we do it a lot. So.
I just wonder how we can get connected, because I'm doing a lot in this area as well. And
With what, sorry?
how we can get connected and take it forward, because I'm doing a lot of things in this area, but you only covered infrastructure as code. I expected it to be more about DevOps. So what about the application lifecycle, configuration as code, security testing, and all of this stuff? Do you have experience in these areas as well? And because I understand 20 minutes is not enough to cover it, so you just focus on small slice of DevOps. That's what I would say.
Yeah.
Because infrastructure as code is one of the DevOps best practices, but just one of many. Yeah.
Mm-hmm.
So do you go deeply into DevOps, into the other areas of DevOps, or only infrastructure as code?
So which areas, for example?
For example, full application lifecycle management, so more about the configuration and other things which data engineers, data scientists are doing on the top of Databricks, how you promote it between environments. And then how you do, for example, testing, how you isolate development environments to give some kind of, separation, how you work with the branching strategy, with the quality assurance in your pipeline, security, and all of shifting left, all of this, what you do in DevOps, yeah?
Okay, yeah, I mean, we do that, and in our pipelines, I haven't shown you in the YAML pipeline, but it is separated by environment, and so we use essentially in the YAML, there's a deployment task essentially that you work with, that you specify the environment and you can add gating onto that to make sure that somebody approves it before it's actually published.
Yeah, so all of these best practices, I'm looking for someone I can discuss things and compare how you do it, how we do it, so could we have some maybe sessions to just share the experience really, because I'm pretty deeply in that, and probably I could have session 3 hours wouldn't be enough, so I appreciate that during 20 minutes you covered a lot, but just...
Yeah, so it'd be good to have like a workshop on how we're approaching that and how we're overcoming those hurdles.
Because I'm interested how the others do that. I spent about 4 years to build some framework around that. I'm doing the same things with a bit different technology because, for example, I was using ARM templates. I know they're complicated, but I'm more powerful and more closer to Azure, yes? And now I'm switching into Wykes. So, and then, because I mostly have because I'm more working with DevOps engineers as well, and PowerShell is more natural for them. So we build pretty comprehensive PowerShell libraries which use REST API and do the same things you do in Python. Yeah. But so as I'm saying, we are doing very similar things, but with a bit different toolkits. So it would be good to compare the experience and how we do things.
Yeah.
There's a solution. Just switch to Synapse. It's easier.
I'm using Synapse now.
Yeah.
Actually, now, I switched to Synapse. Yes, I'm big because I had the same challenge with Data Factory. I was using Data Factory, Databricks, and data warehousing. Now I just use Synapse, and it makes my life so much easier. But there are different challenges.
Do you find DevOps though with Synapse?
Sorry?
Do you find DevOps quite easy with Synapse?
Oh, a bit challenging, but I got there to very high level, including infrastructure.
We've done some good work in the last few months in Synapse.
And with a bit of custom PowerShell, which use REST API, you can do everything. So at the end, whatever was not covered by the standard Microsoft extensions for Synapse DevOps, you have for Azure DevOps,
Yeah.
You can just cover it up with your own custom code because we are software engineers at the end. We can do code. So
Yeah,
it's
so
not
I
big deal.
don't, the teams that I work with, they're not always software engineers. So that's driven the angle of my talk, is that I'm trying to empower data teams, and there's different skill sets in the data teams, and so we're trying to give them some tooling that they can all understand and work with, whereas historically there's always been that one team or one guy who understands it, and he's the only one that understands it, and that completely breaks the DevOps,
Yes.
the DevOps model. The idea of DevOps is everyone understands it, everyone works together.
Absolutely.
So from the clients that I've been working with, this works. But if I was in a software engineering team, I'm totally on board with what you're saying. You can get a lot more technical and get a lot more in depth with
We
it.
actually are trying to have the proper DevOps cross-functional team. So we don't want just to have one perspective. So we don't only have the data engineers. We have in the team some software engineers as well working with them.
Yeah.
And then they do workshops, they share the knowledge, and at one point software engineers knows much more about data engineering and opposite.
Yeah.
And at the end they decide together what technology they use. So I was doing a lot of things with Python as well in the other teams because I'm doing it for different kind of
Yeah.
organizations.
Yeah.
But sorry, I don't want
It's
to really
fine.
spend
Yeah.
time on this session, but for me this is very interesting topic.
Yeah, it is an interesting
I spent a few years of my life to fight against that, build my own toolkit.
It's difficult to
And
know what
it's-
to cover in 20 minutes, because I could have gone down the best practices route, but I really wanted to show people some different options, different tools to pick up if you're really new to it and trying to figure out the best approach. And definitely, if you write Python, then the tools are out there to work with Python. You don't have to learn another new tool like Terraform. You don't have to go down that route.
Yeah, I had to learn Python about 4 years ago because I was software engineer, more C# background. And then when I started working with data engineers, data scientists, I found it's more natural for them. So actually it was easier for me to learn Python than convert them and ask them to learn C#, obviously. So or PowerShell. So at the end, I understand and I fully agree with you. You should choose the kind of technology and language and everything that you have majority in your team. So you don't need to convert everyone.
Are you finishing?
Yeah, we are. Yeah.
Okay.
Yeah. I was originally C# and Scala, and now I write Python most of the time. So it's just whatever job I'm doing at the time. It's good to know more than one language, though.
You need to be more open these days.
Yeah.
These days you cannot just stick to one technology or one thing.
Are there any more questions? Hopefully that was useful to everyone.
Yeah, I'm sure.
It was really good. Thank you very much.
Again, sorry that I talked really fast. Trying to get a few notes.